Okay, the meeting is recorded now. So, hello students. So, in the last class, what we have discussed, we have discussed about three-phase diagram of the soil, and we have discussed about different relation in terms of volume and also in terms of weight. Okay, so till now we are familiar with void ratio, porosity, degree of saturation, specific gravity, air content, percent air of voids, then unit weight of soil, density of soil. Okay, different types of density of soil, different types of unit weight of soil. All these things are now. I think we have understand these things. Okay, and also we go through this what interrelation between different definition or different parameters of soil. Okay, I think all about 6 or 7 relations I have already mentioned to you. So most of all are important. Okay, try to memorize that formula, or you can go through the basic concept how the formula can be derived. Okay, fine. So in this class we are going to discuss about index properties of soil. Okay, now property, you know this, what do you mean by property? Now in case of soil, when you say in case of soil, that a soil must have two types of mainly two types of property. Okay, so one is known as index property, other one known as engineering property. Fine. So what is the main basic difference between index property and engineering property? The basic difference is that the index property is actually used for characterization of the soil. That means to know the type of soil, okay, what type of soil it is, what kind of behavior should it show. So it's only depend on the index property of soil. To know better about the soil, we have to know about the index property of soil. Now, engineering property are actually nothing but the application property. Okay, they are the applied property. Okay, so simultaneously we'll going to learn about all these engineering and index property of soil. So I think Chinumuni ma'am have going through your compression of soil. So compressibility is one of the engineering property of soil. Okay, and like um, shear strength, permeability, or compressibility, they are engineering property of soil or applied property of soil. Okay, so let me first share a screen. Okay, can you see my screen? Can anyone please respond in chat box?
Yes,
My
sir.
screen is visible, right?
Yes, sir.
Okay.
Yes, sir.
Okay, I'll go. Okay. Okay, I think it is class 4. Yeah. So here we are going to discuss about index property of soil. Okay. So basically, I think you can see, right? Okay. So basically, in soil mechanics, the properties of soil are broadly classified as index property and engineering properties. Okay, the properties of soil which are used for identification and classifications of soil, they are known as index properties of soil. So let me introduce to you the basic index properties of soil. They are actually how many? One, two, three, four, five, six. Six, right? So we have six index properties of soil. What is the name of the index property of soil? Like specific gravity, that already we discussed in the last class. Specific gravity is considered as an index property of soil. Then water content, that already discussed. Particle size distribution we didn't discuss yet, but we'll discuss in coming classes. Then in situ density. In situ means in field, okay, or at field. So actually in nature, what is the density of the soil? That means in situ density. Okay, so this is also an index property of soil. Then consistency limit, it's a new term. We're going to discuss about this in coming classes. Then relative density. This is also kind of new term, but density is related to it, so that means it's little bit similar to you. So in total, six. That is the name of the index properties are water content, specific gravity, particle size distribution, consistency limit, in-situ density and density index or relative density. So density index or relative density are same. Okay. So I think from here, I think I can say at least three are familiar to you. Specific gravity, water content, and in-situ density is familiar to you. Other particle size distribution, consistency limit, and relative density, it is kind of new to you. Then we'll discuss in coming classes. Okay. But in this class, I'll just going to I just want to give you some basic introduction to all these four or six, whatever I can. Okay. Let's proceed. So here you can see here again engineering property of soil are like general permeability, shear strength, and compressibility. So we also going to discuss about this. Okay. So these are actually try to remember this. These are termed as engineering property. Fine. Okay. Just I'll do one thing. I'll just open the PPT. Sorry. Oh, back second. Okay. Okay. Yeah. So till now we already discussed about index property of soil, engineering property of soil. Okay, so let's discuss next. I want to share with you that some laboratory determination of some index property of soil. Okay, so here you can see specific gravity that already discussed. What is specific gravity? You know these things. That is a ratio of unit weight of soils. Sorry, it is a ratio of unit weight of soil solid to the unit weight of water, and it is dimensionless. Okay, and it is varies from 2.6 to 2.8 for inorganic soil. I think it is already mentioned in the last class. So specific gravity, which is also termed as the index property of soil, can be determined in laboratory by this method that is known as what? Pycnometer method. So you can see in this diagram also, you can see this is a pycnometer apparatus. Okay, so I think in the student portal also there is there will be a video link or a manual, a detailed manual, or you can also go to the YouTube channel. So you will get some basic idea how to find out specific gravity of soil by using pycnometer method. You just go through this. Okay, so since you know the basics idea about specific gravity, at least you will understand about the procedure how to use pycnometer to find out specific gravity of soil. Okay, so just go through the video link that is given to your student portal. Fine. Next, yeah. So next we'll discuss about water content. So I think you know what do you mean by water content. Next second. Somebody's waiting in lobby. Okay. So water content is defined as what? Weight of water divided by weight of solid present in a given soil mass, and it is expressed in terms of percentage. Okay. So we can also find out that how much water present in a particular soil in laboratory. Okay, so there are numbers of method that we can follow for measuring water content in laboratory, like oven dry method. Here you can see oven dry method is there, sandbath methods is there, pictometer method, rapid moisture method, or calcium carbide method, same thing. Okay, another we can also use torsion balance method. Okay, alcohol method, all our different methods are there to find out water content of soil in laboratory, or in sometimes also you can find out in field. Okay, so among all these method, this oven dry method, which is written in a bold, you can see oven dry method is considered as a most accurate method to find out water content of soil. Oven dry method is what? It is actually in this method we use a thermostatically controlled oven. Okay, where a particular soil sample is put for 24 hours, and after 24 hours, what will happen? The water which is actually present in the soil, it will get evaporated, and we can measure the weight of the soil solid or soil particle before putting in oven and after putting in oven, and by just subtracting that we can find out the weight of the water, and by just dividing the weight of water by weight of solid we can find out moisture content. It is a basic procedure of oven dry method to find out water content or moisture content of soil. So in student portal also you can get all this detail of the manual in soft copy and the video link. You'll get an idea about how to do oven dry method to find out moisture content. Okay, and among that calcium carbide method, it is considered as a quick method. Since quick method means what? The what is the basic disadvantage of Ovendra method is what? To get the value, to get the result of water content present in a soil mass, you need to wait at minimum 24 hours. Okay, you have to wait for 24 hours. But in case of rapid moisture meter or in case of calcium carbon meter, in a very within an hour you will get the result quickly, but it is may not be accurate one. You will not get accurate result of moisture content, how much exactly want water present in the soil. But by using Ovendra method, you will get the exact uh, exact amount of water that may be present in a particular soil. Fine, got it. So at least names are important. Just remember the name of the taste. Fine. X second, please hold. X second. Yes. Sorry. Yeah, please try to remember all these methods, name of the method. Okay. Next, I'll jump to. You just keep it like this. I'll discuss this number three later on. I'll just jump to the next one. Yeah, I think you already familiar with density. Already know, already given an exam a definition of what is in situ density. In situ density means what? The density that is mass per volume. Okay, that is present, or weight per volume. You can also say weight per volume or mass per volume present in field. Okay, so in actual field you can find out the density of soil that is actually present in a particular field. Okay, so the input density or input unit weight also we can say can be defined, can be find out by these two method. Okay, first it is what your by core cutter method, that you can see this is a core cutter method. This is a core cutter apparatus, and another one is sand replacement method. Here you can see sand replacement method. Okay, in our usually we go for this core cutter method. Okay, and this one also we can be done, but okay, you can also go through this one also. So both are actually, the link will be given to you in student portal, so you can go through this link. So I think it's just better to understand this one. Okay, because it is very easy to understand. This is just this is a core cutter apparatus. Okay, which is your, this is called a collar or dolly. Okay, and this is a rammer. Okay, what you have to do, just you need to what, in the ground you need to insert this mold inside the soil, and you have to take out the mold after penetrating the soil. And after taking out the sampler, after taking out the mold, what will happen? The soil will remain inside the this mold. Okay, so just we have to, what you have to do, we just need to the, we just need how much soil is present inside the mold. Okay, we can take the weight in the, just measuring in measuring machine, weighting machine. Okay, and just dividing the, we can divide by this volume. This mold have a standard dimension, standard diameter, standard height. Okay, I think 10 centimeter or 13 centimeter like that. You just go through the standard manual. Okay, so after that we can by dividing the soil present in a particular inside the mold by this standard volume, you will get density. Simple is that. It's a very simple test, so it will be very easy to understand. It's just go through a student portal, the link will be given, the procedure will also be given to you. Just go through the procedure. Okay, and the name of the test is what, core cutter method, to find out insert density. Okay, and also try to remember this one also, sand replacement method. If you require, you can also go through the uh, procedure of the sand replacement method. But remember, these two methods are used for finding what to finding this one, your absolute density of soil. Okay. Okay, excellent. Hold on. Okay, hold on. Excellent. Okay, so I think you have understood these things. Okay, anything else? Yeah. So about this particle size distribution, that is also termed as index property of soil, this particle size distribution we're going to discuss in coming classes. Okay. So I don't want to give so much information right now only. So it will make you only confused. So it is not that complicated. I just want to tell you that in nature, a soil may have different shape and sizes. Fine. And based on sizes, we can classify the soil in different types. Okay, again we have a classification of soil based on sizes. Okay, like the soil having sizes less than sorry more than 0.75 millimeter, okay, or 75 micron, they are termed as coarse grain soil. And a soil having um, sizes, it is a little bit wrong, okay, in this data. I will correct it in the next class. Okay, I will correct this in next class. So till now, just listen to me. The the soil having sizes less than 75 micron, it should be micron. Okay, so 0.0075 millimeter, that soil is known as fine grain soil. Again, in fine grain soil we have two categorization of soil, that is clay soil and silty soil. Okay, and under coarse grain soil we have different soil like sand, gravel, pebble, boulders, all are coarse grain soil. So we'll discuss in next class about this. Fine. So we'll again also find out the grade of soil. So in coming classes we also discuss about what is actually, what do you mean by grade of soil, how many types of grade of soils are can be we can find in soil. We'll discuss in coming classes. Okay, so for now I just want to close my recording here. Okay, X second.